Hi. First of all, thank you, Rai, for inviting us here to tell our story about IPv6 deployment in our network. My name is Liviu Pislaru. I work for RCS-RDS as a network architect in IP/MPLS backbone team. And for about 2-3 years, I'm officially involved in IPv6 deployment in our network. First, let me tell you a few words about our company, one of the most important telecom in the region, providing telecommunication services in 8 different countries. We are the market leader for broadband and TV services in Romania, and Romania is the only quad-play provider of broadband, TV, mobile, and phone with the most competitive prices for all services. Why we did it? Why we did implement IPv6? As you can see on this slide, our last allocation from RIPE/14 was about half a year before and ago, and obviously IPv4 depletion wasn't the trigger. Actually, if you provide dual stack to a customer, you won't solve IPv4 depletion problem because you need an IPv4 address as well. We did it mainly because when it comes to IP/MPLS network in RCS-RDS, we build almost everything in-house, and when you have a do-it-yourself business model, then you have very experienced engineer and an open-minded management to new ideas. We considered that the most important, the ideal time to gain experience as an engineer is when the risk of affecting customer services is minimized. That's why we choose to implement IPv6 when the size of the internet, of the IPv6 internet was less than 0.5%. So I've read an article written by Jeff Houston, the end of IPv4, and inspired by that article, I've drawn this graph that represent our hopes and expectations regarding IPv6 evolution. As you can see, marked with the blue line is the IPv4 pool size for RCS-RDS. We hope that based on our calculation, we will have enough IPv4 resources for another 2-3 years in 2015. And by that time, we hope that the size of IPv6 internet will be big enough, close to 80–90%. So we will be forced to use carrier-grade NAT for a small amount of traffic. I will skip some history details regarding IPv6 evolution in our network because I don't have too much time, but I'll mention that all started in July 2003 when RIPE gave us the first /32. In July 2009, we decided that it's mandatory to have the full IPv6 BGP table. That's why when we renewed all contracts with the upstream providers, we put this on the list. In 2010, we tested, qualified, and shortlisted IP routers with dual stack support in our network. We have a dual vendor policy in backbone. We're using only Cisco and Juniper. The only routers in our network, IP routers, that we enabled dual stack on are Cisco 6500, 7600, ASR9K, CRS, and Juniper MX's 916 Special. 2011, in June, World IPv6 Day, we decided to stop talking and start acting. And 4 months later, in October 2011, we started a pilot project based on sign-up. I'll give you more details on that on my next slides. Our goal was IPv6 to every residential customers. It's important the fact that we are providing now IPv6 only to residential customers because we are using PPP OE authentication. We built up a virtual team from several highly qualified engineers from different offices in Romania. Our main goal was IPv6 deployment in our network. We kept the same IP routing policy as before. We are using the SCPv6 prefix delegation for IPv6. I already mentioned we have a DHSL business model, and we also have a distributed and redundant BNG system that gives us a lot of flexibility when it comes to IPv6. The biggest issue was the lack of IPv6 support on CPEs. That's why we modified the Linux version for embedded devices like OpenWRT to do what we need. We needed IPv6, PVPoE, DHCPv6, and prefix delegation, and then ask for the similar firmware from different vendors like Linksys, D-Link, ZTE, Huawei, Drytech, Freezebox, and so on. And in 2012, all of them have CPEs that support what our customers need in terms of IPv6. So we started the pilot project in October 2011. We announced it with a press release. The program was available in 20 cities in Romania and was based on sign up. And our big surprise was to see that in less than 6 months, 12,000 customers have enrolled to IPv6 trial. And as you can see here on this graph, a third of them actually succeed to connect IPv6 in our network. 6 months later, we ended up successfully the pilot project and decided to give IPv6 to every single residential customers. That's why, as you can see on this graph here, adoption rate percent was around 0.2 in March, all the customers that have enrolled to IPv6 trial. Then around 1% in April, and starting May, the adoption rate was 10%, and at World IPv6 launch this year in June, we had 18.6%, and that places us on the first place among adoption rate among all ISPs. The percentage has been growing ever since because, as you can see, this month, in September, we have 25%, meaning that 1 out of 4 customers in our network are using now IPv6. Let me give you some more details about World IPv6 launch. This is our IPv6 CDN traffic. As you can see, most of the traffic is Google, and 5% of it is Akamai. The traffic, as you can see, didn't increase after World IPv6 launch, mainly because we already have our DNSs whitelisted by Google. The traffic actually decreased because Google started blacklisting some of our DNS servers, and that helped us a lot because we identified and isolated some problems in our network. It was a problem with some BGP session flapping between Quagga on our BNGs and 7600 from Cisco, and we had also a link local problem. Both solved. We decided to measure IPv6 brokenness ourselves. Ignore the green line. The blue line indicates the IPv6 brokenness with more than 50-second delay in our network, and an average is around, I don't know, 0.07, 0.05 or less. So we don't have any problem with brokenness right now in our network. So it was a success story with Google, and let's say a different story with Akamai. Mainly because Akamai traffic was not entirely served from our data center, and we had to pay for it. As you can see here in this example, when a v4-only customer is in our network try to access facebook.com, then all the content is served from the Akamai cluster in our data center. If we move the customer to v6, then part of the traffic, marked here with the red spots, is served from different Akamai clusters in Europe. That's why our traffic increased, our v6 traffic increased in European peerings, and we have to pay for it. And also the latency also